Hello everyone. Today I'm going to show you how we can solve Truss 2D by fixability method. So here in this example we have Truss and applied on node number A. This is node A. Okay, let's me to. Okay, now I can write. Okay, node number A. Applied load 1 kilonewton, a vertical, and on horizontal direction we have 0.5 kilonewton. So the question is find the internal forces and displacement at node A. First of all, to solve this problem, we should find or we should check this figure if determinate or indeterminate. So here, how we can check this one, we should use the equation of a degree of determinant. The equation is equal n plus r minus 2j. M is the number of bars. R is the number of reactions. And J is the number of joints. So here in this example, on this node number 1, this is node number 1, this is number 2, this is number 3, 4. So because we have the hinge, so hinge take 2 reactions on horizontal direction and vertical direction. Also for roller, we have 1 reaction. So now I can check n is 5 plus, because we have 5 members, plus r is 3. The reaction, this is number H1 and V1, and we have V2, so is 3 reactions, minus 2 time joints we have 4. So now equal 0. So this is statically determined. Okay, so here we have a 0. That mean is our truss is settable. So now we should find our the force F equal TR time R plus TX time X. Here is 0. We don't have any value. If the shape is indeterminate, that means we have a value, because as you remember for undergraduate level we have 3 cases. Let me to write another page. The 3 cases for truss. This is take note. Truss, we have 3 cases. N plus r equal 2j, that means statically n plus r bigger than 2j, this is statically indeterminate. Then the third condition, m plus r less than 2j equal unstable indeterminate. Okay, so here this is for undergraduate level. So in this equation, in this example, you should get a number here, like for example 1, 2. Okay, it will be indeterminate, but here get 0, so the shape is determined. So this is, we don't have any problem. However, we should remove one item, this item, because it's determinate, so this items or this part should be removed equal 0. Okay, so that's the equation, or our f, it will be equal tr time r. So let's draw now the next step. We should divided the shape for two parts. Why? Because we have two forces, because we want to use the theory of structure. So the shape is this one, like this. Sorry for my drawing, I don't have rule. Because we have here 1 kilonewton on vertical size, or vertical direction, and here we have 0.5 kilonewton on horizontal side, so that we should remove these forces and assume we have 1 kilonewton for to both directions of force. That's mean our shape, or the first one, is up to you. You should start with vertical or horizontal, up to you. Here I will draw this one. Just substitute. We have on horizontal direction we have 0.5 kilonewton, so I will substitute or assume it equal 1 kilonewton. Okay, plus and on vertical direction same 1 kilonewton. This is assume, so it's not we have not or conditions or other things. Just assume and substitute 1 kilonewton. This the first part I call it TR1, and the second one call it TR2, because I need for both shapes, or for both new shapes, I want their values to find f, because I will substitute for this items, or item for this one, for this part. So next slide, I will find the internal forces for each new shapes. this is 3 meter and this is 4 meter. So, and I should give the number for each node to make it my solution is easy. And this is A, P, C, D, E. Now we have 3 important equations to find the reactions and internal forces. We have summation for horizontal force equals 0 and summation for vertical force equals 0, and also summation moment at any point you want to take it equal 0. These important things it will be help you to find the values. However, then we have roller. Here we have one reaction. I will call it V2. And for node number 1, we have V1 and H1, the force on horizontal part, horizontal direction. Now, we have one force or one unknown force on horizontal direction. It's easy, I can find by summation FH equals 0, H1 plus 1, we have this force 1 that I assumed equals 0, H1 equal minus 1. So here be careful. Let's meet on your drawing. I will draw small parts here to show you the mistake of most of the students. The value is, this is a H1 that I find it, okay, is equal minus 1. So if you want to put in the drawing, be careful with this sign. If you draw in this direction, on positive x direction, you should, when substitute like this one, minus 1. If you change the direction like this, on negative x direction, you should substitute only 1. No need to draw minus 1. This is wrong. Should be 1. So be careful with the sign. Then continue. So I found the H1. Now I can use summation moment at node 4 equals 0, so that V1 times 3 plus 1. 1 is the force that I assumed, times 4 equals 0. V1 equal minus 4 over 3 equal minus 1.33. Should be kilonewton, and this one kilonewton. Okay, then summation FV equals 0. V2 minus 1.33 equals 0. So V2 equal 1.33 kilonewton. So I find the values of reaction forces. Next slide, we go to how we can solve the internal forces, because the first you should find their reactions and then go to find the internal forces. So I will start with node number 1. So I should take the nodes one by one. This is my node number 1. This is node number 1. Okay. For node number 1 is connect with node number 4, so I call this one N14, and this one connect with node number 2, so I will call it N12. And the others, this one is the value of reactions that I found it V1. V1 is minus 1.33 because I draw the arrow in on to the down direction, so no need to put minus, so just put the value. And sorry, for H1 is minus 1. No need for sign because look for the head of arrow direction on negative x direction, so this is 1 only. Then summation for FH equals 0. N14 minus 1 equals 0. N14 equal 1. This is the value of this this bar. Okay, I take the horizontal directions. Then next step, summation for FV equals 0. N12 minus 1.33 equals 0. N12 equal positive 1.33. Okay, this is the value of N12. Then go to node number 2. This is node 1. Node number 2. Node number 2, we have three members. I cut the truss and also have the angle. This is call it alpha. The force is 1 from that I assumed, and this is I call N23, N24. This is the node number 2. Okay. For this one, this is N21 is same 1 2 or 2 1. The value is equal 1.33. That's I already found it. Okay. Then because I have the angle, I should take the sine and cosine to find the angle. Tan alpha equals sine alpha over cosine alpha. Sine alpha is 3 because the dimension is 3. You can get it from drawing this one, 3, and this is 4. So the far is 3 and the near is 4, equal 6.87 degree. Now go to find the internal forces for the node number 2, summation fh equals 0, n23 plus n24 sine alpha plus 1 equal 0. Here we have two unknowns values, so go to summation f v vertical n24 cosine alpha plus 1.33 equal 0. So n24 equal minus 133 over cosine alpha. So I will get minus 1.67. Okay. Then substitute to find n23. n23 equal minus n24 sine alpha minus 1 equal 0. Sorry, yeah, equal 0. I already give the last value. So the for n23 the value is 0. Okay. Now I already finished the shape number 1. So about here about the member of what about the node 3 and node 4? Node 3 and node 4 is already, it will be equal 0. This one is 0 and this one is 0. Okay, because we don't have any applied force on node number 3 and on node number 4. And you can try by your own. You will get 0 here for the node 3 and node 4. So now go to the next TR2. That's mean when you assume the force is equal 1 kilonewton on vertical direction. So here, this is our shape. Now I will take the value of force is equal here 1 kilonewton. This is 4, 3. Same thing and same procedures. Here, because we have 1 kilonewton, okay, it's automatically the reactions to make it the shape is settable. That's unbalanced. This one is 0.5 and this one is 0.5. Okay, but you can calculate by your own. Same steps that I already done in the last or previous tips. You can calculate by your own how we get the reactions, but here I will do only for the moment moment on node number 4 equals 0. So here the reaction is this is R1, R2 and R3. R1 times 3 minus 1 times 3 equals 0. So R1 equals 3 over 3 equal 1. Sorry, this is the R1. This is R2. R2 is equal 0 because we don't have any horizontal force. It's just we have one force and on vertical direction. Now go to find the internal forces for this shape. I will take first node number 1. We have 2 members and 1 reactions. This is 1, 4, and this is N1, 2, and the reaction is positive. I will write 1 only. Summation for FH equals 0. N1, 4. We don't have any others forces on horizontal direction, so it's the value is 0. Summation FV equals 0. N1, 2 plus 1 equals 0. N1, 2 equal minus 1. Node number 2. You should cut the shape to make it easy when you calculate and solve your problem. This is N2, 3, N2, 4, and this is 1. You can find the alpha, same value from previous step. So here the summation FH equals 0. N2, 3 plus N2, 4 sine alpha equal 0. So we have two unknowns. Go to next equation. Summation FV equals 0. Minus 1 plus 1 plus N2, 4 cosine alpha equal 0. This is 0. So N2, 4 equal 0. That's mean the N2, 3 equals 0. Okay. So all values, it will be 0. That's mean only, this one is minus 1, and the other bars equal 0, 0, 0, and 0. You can check by your own. Okay, and that means this is compression. This is compression because we have minus. Okay, next step. Next step, we just substitute the values. So we have F equal TR time R. R is the reactions, how can I say, it's original values. If we go back to your shape or your problem, this one in the figure, we have force on horizontal direction and on vertical direction. So this is, or these are called R value or R matrix value. So for matrix, R matrix is 0.51. Okay, and TR is the internal forces that I already found it in the previous steps. It's TR1 plus TR2. Now I should substitute the for TR1 1.33001 minus 167. How we can put these values? Let me to continue, and now I will show you. So depend on what step I depend to substitute these values. Depends on the name of members. If we go back, yeah, let me to take the shape. This one is A. I call this one A, B, C, D, E. So substitute the values depends on the names of each part. Okay. Time R matrix. Okay. So the last value final minus 0.33 0.5 minus 0.83. This is the internal forces. Okay, now I go to find the displacement at node A. The rule is delta and delta x. This is the general. Let me to just to check. X KRR, KRX, KXR, and KXX times R matrix. Or actually I should write for you the general rule. This is the general. I will depend to find the displacement. So because we have determined shape, so x delta x equals 0 and the x value is 0, so that all values in this matrix has x, it will be equal 0. That means this is 1 0 0 and 0. So we have only this part. Delta equal KRR, or some references they call it FRR, time matrix R, or R matrix. What is the FRR? FRR equal transfer TR time small f time TR. What is the TR? TR is this one, this matrix. It's come from internal forces for when you divided the shape for two parts, depends on how many forces applied on your figure. Maybe in some examples we have three forces. That means you should add TR3. But here in this example we have just TR1 and TR2. So this matrix should be substitute for TR matrix or TR parts in the next step here. And same matrix, just make it transfer, okay, or inverse. Sorry. I'm very sorry, I have my mistakes. So for this, take inverse this matrix. And for small f is the length of each part, each par. Let me to show here. This is your figure. Sorry for my bad drawing. This is 3. This one 4. And this is 3 because it's square, and this is 4. This is already, it will be 5. Sorry. This is number A equal 4, B equal 3, C equal 4, and D equal 3. And E can by Pythagoras, 4 square plus 3 square, you will get 5. And when you substitute these values for small f, the rule of small f, L over EA, A, B, C, D, E. This is the matrix, and the other part should substitute any client, because we have matrix here, and when you multiply two matrix, you should check the number of columns and number of rows. So the others part 0, and this one equal 0. No values, just substitute 0. That's all. Then do your I'm very sorry. Do your or find displacement now, because everything you have. So delta equal 1 1 over EA oops, sorry, something is mistake. Okay, I will explain here. Sorry, I'm very sorry for. I'm very sorry. Small f equal L, or the original part L EA equal 1 EA, because I entered the L and put it in the matrix. That means LA, LB, LC, LD, and LE. Okay, and the others is 0. So now substitute for displacement. Displacement equal 1 over EA. Inverse the matrix. 1.33, 0, 0, 1, minus 1.67, minus 1, 0, 0, 0, 0. The F small f 4 3, let me, the length of each bar 4 3 4 3 5, the others elements is 0, and then tr is 1.33001 minus 1.67 minus 10000, okay, time the R matrix 0.5 and 1. Okay, so the after multiply this matrix, you will get the value is like this one, delta equal 1 over EA, because in this example we don't have the value of EA, so just take it as constant. Okay, but if we have the values, just multiply by this matrix, you will get the original or sorry, exactly the value of displacement. Thank you for watching, and I'm very sorry for my mistake. See you in the next videos. Thank you so much.